Here's the solution for day 4, problem 1. A pole is 4 feet high and has a 6-foot shadow. At the same time of day, a nearby tree casts a 20-foot shadow. Sketch a diagram, use similar triangles in the diagram, and create a proportion to find the tree's height. So here's the ground and a pole, which is 4 feet tall. If the sun is somewhere up to the right and the sunbeam comes down at an angle like this, then the shadow will be on the left side of that pole. We're told that that's 6 feet long. There's a nearby tree, and its shadow will be to the left side of the tree. We don't know how tall the tree is. We can call it X, and the shadow of the tree is 20 feet. Now it says to use similar triangles. So to complete a diagonal on both of these triangles, now we have a large triangle and a small triangle, similar right triangles. So in question B, we can create a proportion to relate the measurements in this drawing. So 4 compares to 6 as X compares to 20. This proportion is an equation which we can solve for X with one step of work. Because this says divide by 20, we could multiply both sides by 20. 20's crossed out, the letter X is now alone. So 20 times 4/6. 20 times 4 is 80 over 6 equals to X. And a little bit of simplifying here to make this problem fit the situation that we're doing here. So 6 divides into 80. Let's see, 6 into 8 once with 2 left over. 6 into 20 3 times with 2 left over. 2 over 6 reduces to 1/3. So 13 1/3 feet. That's how tall the tree is. Day 4, problem 2. Question A. -8 times 7 is -56. Question B. -50 divided by -10 is 5. Question C. We want to subtract these fractions. We can do that if we have the same denominator. I'm going to leave this denominator as 6 and then change this denominator so it's also 6. Times 2 times 2. 5 subtract 4 is 1/6. Question D. 16 divided by 1/3. How many thirds are in 16? So 16 times 3 is one way to find this answer. That is 48. There are 48 thirds in the whole number 16.